Good morning, everyone. So, today in today's session, we'll be talking about one important classification method, that is decision trees. So, this is also part of your syllabus given in AI. So, that is learning decision trees. So, as in previous concept, we have learned about different classification or different types of machine learning paradigms. As part of that, we have learned about supervised, unsupervised, and reinforcement learning. So now let's talk about one important supervised learning technique called as decision tree. So there are many algorithms which comes under supervised learning, and decision tree is one among them. Okay, so decision tree is a supervised learning technique that can be used for both classification and regression. So while explaining about supervised learning, I said that both classification and regression comes under supervised learning. So classification is creating classes and accordingly deciding some according to the input provided, you will see the output. And regression is used for prediction. But decision tree can be used for both the purpose. That is, it can be used for classification of the given data samples, and also it can be used for prediction. But mostly it is used for classification of n number of problems. That is, it will be using a tree structure to classify its data. So I'll be just representing a decision tree for your understanding, like what will be a decision tree. So here you can see a small example of your decision tree, which about a student and also about whether a person buys a computer or not. So we'll be understanding about this while we are learning the example. But for your understanding, I'm just representing this with the structure. So this is a decision tree structure. So we'll be talking about this in the today's slides about what are the structure of this decision tree with all sort of uh, examples. Yeah. So as you have seen the tree, initially you'll be having a root node, and from there you'll be having left side, right side branches. So they are called as your child nodes or leaf nodes, right? So where internal nodes represent the features of data set. So you'll be having a data set with a number of features. Yeah. I'll be just showing you a sample data set also for your understanding. So here you can see this is a small sample data set with 5 columns, that is age, income, student, credit card rating, and this is the class label. So in any classification technique, the last column will be indicated as the class label. That is a decision making step. That is whether yes or no. So using these 4 columns, we are getting some decision. Okay. So this column will go as void. That is just a representation of your number of attributes of your data set. Okay. Yeah. So let's now try to understand the structure of this decision tree. So here the internal nodes represent the features of a data set. So in a data set, we will be having set of features, and that features will be represented using your internal nodes. Branches represent the decision rules, and each leaf node represents the outcome. Okay, so you need to remember this terminology, guys. Internal nodes represent the features in a given data set. Branches represents the decision rules, and each leaf node represents one outcome. Okay, yeah. So in a decision tree, there are two nodes, that is decision node and leaf node. So decision nodes are used to make any decision and have multiple branches, whereas a leaf node are the outcomes. As I said, it will be the output of the decisions and do not contain any further branches. The leaf node will be the final node from which we will be making some decision trees. Okay, so it is very easy implementation or easily understood because of the tree like structure. So the tree structure makes it easy to understand how to make some decision. So a decision tree simply ask a question whether from the given set of samples the decision should be yes or no. So depending on that decision, it further split the decision tree into some subtrees. Okay, let's try to understand the immediate concept of this decision tree. So initially decision tree was developed in the early 70s. So at that time it was known as ID3 algorithm. So in decision tree classification, there are different types of decision trees. The first among them was ID3, which stands for iterative dichotomizer. After that, there were some problems in decision making with the ID3 algorithm, and the next successor of that ID3 is C4.5, which became a benchmark to which newer supervised learning algorithms are often compared. So as a hierarchy, we talk about decision tree like first it is ID3, next C4.5, and next we will talk about J48, which is also a decision tree structure. But J48 is just the Java implementation of C4.5. So whenever you are trying to make some decisions with programmatically, so you will be having J48 as the Java implementation of C4.5. So we'll try to understand what is this ID3 and what is this C4.5, how they are differentiated, and what is the updation of C4.5, how this is different from ID3. These all things we will try to cover in today's concept. Okay, yeah. So here you can see a small structure representing a decision tree. So as I said, the top node is called as the root node or the decision node. So decision tree contains categorical data, basically yes or no, as well as numerical data. So here you can see that at the top, the green color one indicates the decision node, which is the root node. And next we have a subtree with the, again a decision node and a leaf node. And as I said, a leaf node will not have further branches. That will be the outcome of the decision tree from which we will be making some decision. So here you can see the further implementation or the further subtree. So if it is a leaf node, it will not have further branches, and if it is a decision node, it has some further branches. So everybody should keep this in your mind while learning your decision tree concept. Okay. So coming to the terminology of your decision tree, as I said, the root node is from where the decision tree starts. So whenever you are having some given data set, the first step what we do is to decide what is the root node. So to decide the what is the root node, we will be having many strategies which we will be learning in today's session. Okay, so a root node represents the entire data sets which further gets divided into two or more homogeneous sets. As you can see here, initially you will be having a decision node, and from the decision node you will be following some sub branches which can be further taken as some decision making parameters, or they are called as your subtree with decision node and leaf node. Next one is leaf node. As I said, leaf node is the output node or the final outcome node, and the tree cannot be segregated further after getting a leaf node. So leaf node will be the final node in the decision tree. So the next terminology here is splitting. So from the given data set, we need to decide which is the root node and what is the leaf node, and how to make some decisions. And that can be done using your splitting criteria. Splitting is the process of dividing the decision node or the root node into subnodes according to the given conditions. So here you can see a decision node is further split into some other subtrees. So how this can be done is called as the splitting criteria or splitting. Next, subtree forms by the splitting the tree, and it contains a decision node and the further leaf nodes. And pruning is the next important concept about your decision nodes. Pruning is the process of removing the unwanted branches from the tree. So while making some decisions, you will be having many different types of parameters in your decision tree, and sometimes some of the leaf nodes or some of the decision nodes will not be useful for decision making. Those should be removed. That process is called as pruning. So pruning is the process of removing some unwanted branches from a given tree. And the last one is the child node. The child node or the parent node indicates the root node of the tree is called as the parent node, and other nodes are called as the child nodes. So here you can see the top one is called as the parent, that is the root node, and the remaining are called as the child nodes. Yeah, that's a terminology about your decision tree with the concept of decision tree, and how this can be done. We will be seeing about the in the next slides. So why we use decision trees? So there are some reasons why we go for decision trees for a decision making. So basically, decision trees usually mimic human thinking, so which makes it easy to understand about how to make some decision. So from the root to the leaf node, there will be some set of parameters and decision making elements, and it will be easy for a human being or for a machine which thinks like a human to make some decisions. So the logic behind this decision tree can be easily understood because it shows a tree-like structure. So because we are using a tree-like structure, it will be very easy for us to understand a decision tree and accordingly we can make some decisions. Yeah. So what is the working of this decision tree algorithm? How does it work? So as I said initially, we will be given some data set. We need to decide what is the root element, and once you decide the root element, you need to decide the subtrees, and finally you need to come to your root leaf nodes. So accordingly, it will be moving from bottom to top, and it will be making some decisions. So in a decision tree, for predicting the class of the given data set, the algorithm starts from the root node of the tree. So initially we start identifying what is the root node, and then we'll identify what is the subtree, and accordingly we will identify what is the leaf node. So this algorithm compares the values of root attribute with the record or the real data set attribute, and based on the comparison, it follows the branch and jumps to the next node. So accordingly, you can see here, suppose if I'm talking about this step here, initially we will talk about what is the root node, that is the main criteria in your decision tree, and accordingly it will try to come to the subtree, and it will try to make some decision, then it goes jumps to the next branch, and accordingly it will make some decisions. So for the next node, the algorithm again compares the attribute value with the other subnodes and move further. It continues the process until it reaches the leaf node of the tree. So once a leaf node is reached, it will try to check whether the output is occurred, and it will go for the next subtree. So this is the pseudocode or the step-by-step representation of your decision trees. At the step one, we will be starting at the root node. We call it as S, which contains the complete data set. So all the attributes, whatever you are going to have in your data set, they will be initially represented with the root node. So finding the best attribute in the data set can be done using your attribute selection measures, which we'll be discussing in the next slide. So if you want to select what is the root node, or what is the subtree, or what is the leaf node, you need to follow some attribute selection measures. So among the given attributes, which attribute should be selected as the root node for the decision making? So that can be done using your attribute selection measures. So the step two will be finding the best attribute in the given data set using the attribute selection measures. That's what we call it as a splitting criteria. And step three, we divide the S into subsets that contains possible values for the best attributes. So from the root node, once it is identified, we go for the subtree selection, and accordingly we will be trying to select the best attributes from top to bottom. And step four, it generates a decision tree node which contains the best attribute. So decision tree node will be finally obtained, and accordingly we can select the subnodes which contains the best attributes. So recursively it makes new decision trees using the subsets of data set created in step 3. So accordingly it will form the sub branches with respect to number of attributes given in your data set. So this process will be continued until a stage is reached where you cannot further classify the nodes and call the final node as the leaf node. So if you cannot further decide your node into further splitting criteria, we call it as a leaf node. That means it is the final node and we cannot divide the node into subtrees. So this is a brief algorithm about your step-by-step procedure of implementation of your decision tree. So accordingly, we will be having some algorithm which according to your decision tree, but you need to remember this step-by-step procedure for your examination. Okay. So as I said, you will be having some attribute selection measures about which element should be decided as the root element, and which element should be come to the left side of your decision tree, and which element should come to right side of your decision tree is selected using your attribute selection measures. So talking about your examination point of view, this is very, very important question. So you need to learn about this attribute selection measures. So to solve the problems of your decision tree, to make your tree understand what is the root and what is the subroot or the best attribute splitting criteria, we use attribute selection measures. So to select your attribute selection measures, we are having some techniques. As you can see, the first one is information gain, and next one is Gini index. So if you want to know about information gain, you are having one more important measure called as entropy. So entropy, information gain, Gini index, and gain ratio. All these four are the techniques which are used in a decision tree to make a proper decision. But these two are considered as the important metrics when you're talking about C4.5 and J48 algorithm. So if I talk about ID3 algorithm, entropy and information gain are the attribute selection measures. If I talk about C4.5 and J48, Gini index and gain ratio also come under this attribute selection measures. So we need to understand that we are having four important metrics or attribute selection measures which are used in a decision tree to make an effective decision. Okay, so let's try to understand what is this information gain concept and what is this Gini index and what is the entropy in the decision tree. So information gain is the measurement of changes in entropy. So as I said, you need to compute your entropy for each attribute in a given data set, and according to the entropy values we need to measure the changes in the entropy after the segmentation of a data set based on the attribute. So once the attributes are segmented, there will be some change in the entropy, and that's the purpose we will be measuring this information gain using your entropy. So if you want to calculate your information gain, you need to first calculate your entropy. So how to calculate entropy and information gain, I'll be showing with example in the next slides. So it calculates how much information a feature provides us about a class. So each attribute or each feature has some information. According to that information, whichever the given attribute has maximum value among all the attributes, that will be selected as the best criteria for making some decisions. So according to the value of information gain, we split the node and build the decision tree. So for every attribute, we calculate information gain value, and according to the information gain value obtained, we split the node and build a decision tree. So information gain is the major important concept in your decision tree. Okay, so a decision tree algorithm always try to maximize the value of information gain, and an attribute having the highest information gain is split first. So everybody should keep this statement in your mind. So if in a decision tree, information gain value should be maximum if you want to select a best splitting attribute. Okay, so suppose if I say I'm having four information gain values. Among these four information gain values, whichever the attribute is having highest value, that will be selected as the first best splitting criteria. The second value will be taken as the second best splitting criteria. Third and fourth. Accordingly, in the according to the values of this information gain, it will be splitting its attribute values. Okay, yeah. So these are the mathematical representation of information gain and entropy. So as I said, entropy reveals the impurity or uncertainty in a given traffic or runtime data of a network. So in chapter 3, we talked about uncertainty measures, and there we have seen about what is uncertainty. So if you want to know how much uncertainty is available in your data or in a given data points, you need to compute entropy. So entropy, yeah, here basically we have missed a minus symbol here. So entropy formula is minus sigma mod SV by mod S log mod SV by mod S. So the minus symbol is missing here. So okay, so using this entropy formula, we will be computing these impurity measures. So with the example, we will try to understand how to compute entropy values and information gain values, and that will be an easy understanding for you about what are these measures. Okay, so here as in the we have said in the previous steps, S indicates the number of samples in the given data set. C denotes number of classes, and mod SV or SV refers to a subset of S that belongs to a specific class C. And F indicates F here information gain indicates features, and V indicates the value of a given feature. So everybody should note these two important metrics, which are very, very important in a decision tree. In examination point of view, you will be given sort of examples or a questionnaire, and accordingly you need to compute information gain and entropy, and you need to solve your problem. And in examination you will be definitely having a problem with respect to your decision trees. Okay, so for that these two metrics are very very important. So if you want to compute information gain, you will be using entropy measure also. Yeah. So this is a small representation or example data set which we will be taking for understanding the concept of your decision trees. So talking about this data set, so here you can see, as I said previously, you are having 5 columns. The first column indicates age. Yeah. So in this data set, we are having 5 columns, or we call them as 5 attributes. Age is one important attribute, income is one important attribute, student is one attribute, and credit card rating is other attribute. The last column in the given data set is a class label, that is about whether a person buys a computer or not. The last column always indicates a binary value, that is yes or no values. So here the problem what we are having is, according to the given samples, here we are having only 14 rows, but basically in the real-time data set we have lakhs of rows. And according to the given attributes, we need to understand whether a person will buy a computer or not, depending on his age, depending on his income, whether he is a student or working employee, and what is his credit card rating. So I will take these 4 parameters into consideration and I will make my decision. So accordingly, a decision tree also will be trained with the given samples of data set, and whenever a new attribute is given, it should make a decision whether a person will buy a computer or not. So accordingly, we need to make a classification algorithm for this given data set, and finally we need to construct a decision tree to make some decisions. Okay, so everybody need to understand what is the given data set first, and then we will be going on for how to understand about this given data set. The last column indicates the class label to make some decision whether it is yes or no. For that make decision making, we are going to use all these 4 attributes, and as I said, for every attribute we will be computing the information gain and entropy values. The attribute which is having the highest information gain value, that attribute will be selected as the root node. The second highest value is selected as the left side node. The third highest value is considered as the right side node. So accordingly, it will try to construct a decision tree for the given data set. Yeah. So I'll just show you example representation of this data set. Okay, so this is what I'm talking about. This is a sample data set what we are having, and here you can see info of D indicates the entropy values. So if you want to compute your decision tree, or if you want to compute your information gain values, we need to first consider about the entropy values. So here you can see this is your entropy value. So info of D indicates entropy, and entropy values are calculated according to the for the complete data set. So here you can see 9 by 14 log 9 by 14 minus 5 by 14 log 5 by 14. So what is 9 here and what is 14? 14 is the number of rows here, indicating number of rows or number of values given in a data set, and among which 9 is number of yes in the given data set. Here you can see, you can count your number of yes in your given data set: 1 2 3 4 5 6 7 8 9. So in the given data set we are having 9 yes values and 5 no values. That's what is the computation of your entropy. So among the 14 attributes, how many values are predicted as yes and how many values are predicted as no? That's why that's how we compute a entropy for a complete data set. So here you can see the value is 0.940. That is the entropy value obtained. This entropy value, whatever is obtained, will be used again in your information gain values. So again, you can see here now, as I said, this is the calculation for your entire data set. In the entire data set, how many samples are, how many values are taken as yes, and how many values are considered as no. That's how we are using your, you're getting the value of your entropy for your complete data set. This is for your complete data set. Now we will calculate for individual attribute. That is, initially we talk about this attribute called as age. Now I am computing this information gain values. Now I'm computing the entropy values for each column. So here you can see info of age. That is, I'm calculating the entropy value for age column. Similarly, I'll compute the value for your income column, for student column, and also for credit rating column. Likewise, you need to compute four entropy values for four columns. So now again you can see here again a 5 by 14, and in these 5, suppose if I talk about age, in age we are having three different types of age, that is youth, middle aged, and senior. That's what you need to understand. If I want to compute about individual attribute, we need to see in that attribute how many types of classification is there. If I talk about age attribute, I am having three important metrics, that is youth, middle aged, and senior. So if I talk about youth, so in youth, how many people are, how many youth are there in the given data set? Suppose if I say in the 14 at 14 rows here, I'm having 1 2 3 4 5 youth, right? Among 14, I'm having 5 rows as youth. And how many middle aged? 1 2 3 4. That is 4 are middle aged, and remaining 5 comes under your senior category. So the age attribute should be computed like this. So here I am having 14 attributes, among which 5 are youth. Again, among 14, 4 indicates middle aged, and among 14, 5 indicates senior. That's why I am having three calculations here. That's why in the formula we have said summation of mod SV by mod S into log mod SV by mod S. So among the 5 youth, how many of them are yes and how many of them are no? So among the 5 youth attributes, I'm having only 2 attributes as yes. That's why 2 by 5 log 2 by 5. And remaining are no, that is 3 by 5 log 3 by 5. Similarly, for middle aged, there are always yes. So middle aged, you need to compare only this. Now assume that these 3 columns are empty. You are having only these 2 now. So middle age and yes, that is 1 2 3 4. So we are having 4, and there is no for this middle age attribute. That's why you are having not having any further classification. So if I talk about senior value, in senior I'm having 3 yes and 2 no values. That's why 3 by 5 log 3 by 5 and 2 by 5 log 2 by 5. Now I am able to compute the entropy value of your age attribute. Now I need to calculate the information gain value, for which I'll be using this computation. So gain of age is equal to entropy of D, that is complete dataset value, that is 0.940 minus information gain of entropy of age, that is 0.940 minus 0.694 is equal to 0.246. Similarly, you need to compute information gain for income, information gain entropy value for your student attribute, and entropy value for your credit card rating attribute. So accordingly, you will be getting your gain values like this. So I got gain value of age as 0.246, gain of income as 0.029, gain of student is equal to 0.151, gain of credit card rating is equal to 0.048. So among these 4 values, whichever the value that is highest, that is gain of age, that is 0.246 is the highest value. That's why I will take that as the splitting criteria. I'll just show you. Wait. Yeah, so here you can see, because among all the values computed, that is 0.246, 0.029, 0.151, 0.048, age has the highest information gain among the attributes. It is selected as the splitting attribute. That is, a root node is considered as age here. So you can see here the decision tree constructed at the end of this algorithm, that is age, that is the root node, and next highest value is obtained for student, that is 0.151. That's why student is considered as the next decision making node. And next we can see for credit card rating it is 0.048, and the last one is 0.029. It is ignored because as I said, during your decision tree making, whichever attribute is not used, that will be pruned. So we have learned about that here as pruning is the process of removing the unwanted branches from the tree. So here I don't want income attribute for decision making, that's why it is being pruned here. So remaining attributes will be considered as the decision tree elements. Okay, so now with this decision tree, you are forming some association rules. Some rules will be obtained, and here you can see, suppose if I talk about one student, the next new input, if I take, suppose if I take the person as youth, and if he is youth and he is not student, if he is youth and if he is not student, then whether he may buy computer. So because you can see, if there is a no student, if a person is not a student, then if he is a youth, definitely he might be earning, that may lead him to buy some computer. And if person is a middle-aged person, definitely he will be buying a computer. According to the given data set, this is the decision tree formed for the given data set. Okay. Yeah. That's it about your decision tree, guys.